multiplication examples, the first thing we still want to do is factor completely. So I'm going to look at the top of the first fraction, and I notice that that's a difference of squares, so I can factor that as 2a minus b times 2a plus b. And same on the bottom. I can get 2c minus d times 2c plus d. Now the second fraction's a little trickier. So if we're squaring a fraction, what that does is that squares both the top and the bottom. So this fraction we can rewrite as 2c minus d squared over 2a plus b squared. And now we need to see what we can cancel. So I see a factor of 2a plus b, and I have two factors of 2a plus b in the second fraction. So this is going to cancel and become a 1. And sort of the same thing with 2c minus d. I have 1 in the bottom, and I have 2 on the top over here, so that exponent is also going to cancel and become a 1. So now let me write my combined fraction. So I have 2a minus b times 2c minus d all over 2c plus d times 2a plus b. And my final step is just to multiply this all out so that I have it in simplest form. So let's see what I get. I get 4ac minus 2bc minus 2ad plus bd. And on the bottom, I get 4ac plus 2ad plus 2bc plus bd. All right, so that's my simplified answer. In this next example, I need to factor all 4 parts of these two fractions, so the top of each fraction and the bottom of each fraction. So let's look at the top left first. So 4c squared minus 8c minus 5 is a trinomial, so I know I'm going to get 2 factors. And in this one, we normally look at the squared term first, but maybe with this one, since we have a 5, it's easier to look at the constant term. So we know one of them must be a 5 and one of them must be a 1. And so we want to place factors of 4 in such a way that we'll end up with 8 in the middle. So I don't think that 4 and 1 will work. So let's try 2 and 2. So if I have a 2c and a 2c, that's going to give me 10c and 2c, which will allow me to get 8c, negative 8c, as long as the 10 is negative and the 2 is positive. So that's how I factor the top. Then I need to factor 12c squared plus 46c plus 40. So the first thing I notice about this one is that 12, 46, and 40 are all even integers, so I can at least pull out a factor of 2. So I pull out a factor of 2, I have 6c squared plus 23c plus 20. Okay, and then on the second fraction, I can pull out a greatest common factor of 4. So I have 4 times 5 plus 2c over 5 minus 2c. So I can't really factor that bottom right polynomial at all. Okay, so last step for factoring, I need to go ahead and break down this trinomial right here. So let's do that. So we'll have 2c plus 1 times 2c minus 5 over 2, and then we know we're going to get 2 factors over here, times 4 times 5 plus 2c over 5 minus 2c. Okay, so this one's kind of tricky because we have a few different things we could choose, but maybe we just start with, I don't know, 2c and 3c and see how that goes. All right, so we have 2c and 3c, and then I want to find a way to get 23. So how could I do that? Well, if I put 4 here and 5 here, that's not good because I would get 10 plus 12, that's 22. It's close, but not quite what I want. If I put 5 here and 4 here, okay, that's 8c plus 15c. That works. So good. So both of these should be positive. And look, so 2c plus 5 matches my 5 plus 2c diagonally, so that's a good sign. So that means this is probably right and we can cancel. Okay, so now let's see what I can cancel. Well, I just said I can do 2c plus 5, 5 plus 2c. And then here I see I have 2c minus 5 and 5 minus 2c. So those are really, really close to each other, but not quite the same. So when you get two factors where one is backwards from the other, but other than that, they look exactly the same, basically all we need to do is factor out a negative 1. So we can just factor out a negative, and we'll switch these around. So we get 2c minus 5, and now these two are going to cancel. So lastly, we can do the 2 and the 4, and we'll be left with a 2. So my final answer, before I multiply it back out, is 2 times 2c plus 1 over negative 3c plus 4. So basically all I can do from here is write the negative outside, distribute in the 2, and so we get 4c plus 2 over 3c plus 4 with a negative sign out front. Okay, so if you were to type in something like this, just make sure the negative is level with the fraction bar and not like the top or the bottom, because if you were to put it with the top or the bottom, the computer is going to assume that it goes with either 4c or 3c, but not the entire numerator or denominator. Okay, now we're going to look at some division. So we just did multiplication, and division is very similar, except we just have to remember the keep, change, flip. So let's get to work factoring this first one. So we have 2x squared minus 11x plus 12 over 27 minus 18x is our first fraction. So the top is a trinomial. I'll go ahead and set up my two factors. There's only one way to factor 2x squared, so we get 2x and x. And then I need to find a way to factor 12 so that I get negative 11 as my middle term. Okay, so let's think about this. If I use 4 and 3, I think that will actually work. So if I put 4 here, that's going to give me 8x on the outside. If I put 3 here, that's going to give me 3. So I can definitely get 11 out of 8 and 3 if both of them are negative. And on the bottom, I just have a greatest common factor situation. So the greatest common factor here would be 9. So I have 9 times 3 minus 2x. All right, and then divided by, so I can factor x cubed plus 4x squared by factoring out a factor of x squared, and I'm left with x plus 4. And then on the bottom, I can factor out 6x, and I'm left with x squared minus, let's see, what's 96 divided by 6? 16. Okay, that makes sense that it would be a perfect square. Okay, so let's now keep, change, flip. So we have 2x minus 3 times x minus 4 over 9 times 3 minus 2x times 6x times x minus 4, x plus 4. So I can break that x squared minus 16 down further because it's a difference of squares. And then I'll have x squared times x plus 4 switching to the bottom. Alright, so now I have a fully factored form. I've keep, changed, and flipped my problem. So now I can get to work canceling. So maybe the first thing I notice is x plus 4 and x plus 4. I've got 9 and 6, so I'll get 2 and 3, x and x squared, leaves an x on the bottom. And then I also have 2x minus 3 and 3 minus 2x. So this is another situation where these are going to cancel, but I'm left with negative 1. Because they differ by a factor of negative 1. So let's write down what I have left. So I have 2 times x minus 4 times x minus 4 on the top, and on the bottom I have negative 3x. So the very last step is just to FOIL out the x minus 4's. So I have 2 times x squared minus 8x plus 16 all over negative 3x, which then distributing the 2 gives me 2x squared minus 16x plus 32 all over negative 3x. Okay, so that's the fully simplified form for that one. So now let's look at a trickier one. So in this next one, we don't have such big things to factor, but I have 3 things to divide. So again, I'm going to start by factoring everything. So I have 6y over, I can pull out a factor of 2, so I'll have 3y minus 7 divided by 21 over, I can pull out a factor of 3, and I'll be left with 3y minus 7, and then divided by y squared over 35. Okay, so the tricky part about this is just to make sure that you do one thing at a time. So we can't divide all 3 things at once. We have to take each pair at a time. So first, I'm going to keep change flip the first 2 fractions. So I'll keep 6y over 2 times 3y minus 7, change it to multiplication, and then I'll get 3 times 3y minus 7 over 21. And then I'll just copy the rest of the problem for now. So divided by y squared over 35. Alright, so let's see what I can cancel in just this multiplication problem right here. So I have 3y minus 7, 3y minus 7. 6 and 2 will cancel, and I'll be left with a 3 on top. And 3 and 21 will cancel, and I'll be left with a 7 on the bottom. So now let's see what I have left. So I have 3 over 7, 3y over 7. I think that's all that's left. Divided by y squared over 35. So now I take this division problem as a second step. So I'll keep change flip again. So I'll get 3y over 7 times 35 over y squared. I cancel the 7 and the 35. I'm left with 5. I cancel the y and the y squared, and I'm left with y. So my final answer is 15 over y. Alright, next let's look at some fraction addition and subtraction. So in this first one, we have x squared plus 1 over x squared minus 1 plus 1 over x plus 1 plus 1 over x minus 1. So once again, first step is always completely factor everything you can. So really the only thing I can factor here is the denominator of the first fraction. So I'll get x squared plus 1, and x squared minus 1 is a difference of squares. So it's going to factor into x plus 1 times x minus 1. And my other 2 fractions, I can't factor those denominators or numerators at all. So I'm just going to leave them like this. And it may help when you're first starting out with this stuff is put anything that's a factor, like x plus 1 or x minus 1, always get in the habit of putting that in parentheses because it'll remind you whether you can cancel or not. Okay, so now we want to find the least common denominator of these 3 fractions. So your first instinct might be to multiply all 3 of them together, but we can actually do it better than that. So we don't always just multiply all the denominators we have. We want to look for the smallest thing that sort of encompasses all of your denominators. So here we have 2 denominators that are 1 factor, but we have one of the fractions has a denominator that's both of those factors together. So I think that that's the best choice for our least common denominator. So we're going to go with x plus 1 times x minus 1 as our least common denominator. So we write all 3 of our fractions with the same LCD. And then we'll get to work on figuring out what the numerators should turn into. Okay, so the way we do this is just like with regular numbers. You sort of ask yourself, what did I multiply the original denominator by to get to the least common denominator? And then you should multiply by the same thing in the numerator. So for the first fraction, we didn't multiply by anything because we already had the least common denominator. So that numerator isn't going to change one bit. In the second fraction, to go from x plus 1 to x plus 1 times x minus 1, we were missing the x minus 1. So we have to multiply by that on the top. And then in the third fraction, I had the x minus 1 in the denominator, but I was missing the x plus 1. So I'll go ahead and write that on the top of that third one. Okay, now our job is just to combine across the top, just like with regular fractions. So we'll get x squared plus 1 plus x minus 1 plus x plus 1. all over x plus 1 times x minus 1. So let's add like terms. So we have positive 1, negative 1. And this is equal to x squared plus 2x plus 1 over x plus 1 times x minus 1. So last step, we need to see if we can simplify this anymore. So I think we can factor the top into x plus 1 times x plus 1. And that's still over our common denominator, x plus 1 times x minus 1. And now you notice x plus 1 cancels on the top and bottom. And my final answer is x plus 1 over x minus 1. All right, let's do one more like this. So this time, I can factor more than just the first denominator. So first, we'll have a plus 2 over, let's see, this will be 2 factors because it's a trinomial. We'll have a, and we'll have 2 and 3. That should work. Okay, minus 2 plus a over 2 minus a times 2 plus a plus 2 minus a over a will go in each factor, and then to get positive a in the middle, we can do 3 and 2 again, but the 3 better be positive and the 2 better be negative. All right, so that's our fully factored form so far. So let's see what we can do from here. Well, I see that some stuff actually reduces, so maybe we should do that. That way our least common denominator won't be as large. So if I go ahead and cancel the a plus 2's and the a plus 2 here, and the 2 minus a and the a minus 2, I'll be left with a factor of negative 1. So now I'm left with 1 over a plus 3 minus 1 over 2 minus a minus, because I had the negative 1 right there, so I have minus 1 over a plus 3. And now, actually, in this one, it looked difficult from the get-go, but now I see I don't even actually need to find a least common denominator, because I have 1 over a plus 3 and negative 1 over a plus 3. So those are just going to add to 0, and I'm left with negative 1 over 2 minus a, which you could actually also write as 1 over a minus 2. Doesn't matter. So either of these would be the correct answer. All right, and finally, let's look at some complex fractions. So actually this first one, by request, was number 21, I believe, on the worksheet. So go ahead and look back at this one. So let's see how we can do this. So the way to think about complex fractions is it's basically taking everything we just did, addition, multiplication, division, subtraction, and simplifying fractions, but now it's like a fraction made out of fractions. So there could be a fraction problem in the top of the fraction and in the bottom of the fraction. And so you kind of treat those like two different problems until they're simplified to the point that you can just divide them. Okay, so we're going to see that when we get going with this. All right, so my first one, I have x squared over 6 minus 9 over x squared, all divided by 3. So the first thing I'm going to focus on is just this part of the fraction. So you notice in the numerator, it's a subtraction problem. So the least common denominator of 6 and x squared, well, they have nothing in common, so I can just multiply these two. So I'll have 6x squared and 6x squared. So x squared over 6, the 6 was missing the x squared, so I need to multiply by x squared and get x to the 4th. And then in the second fraction, the 9 was missing the 6. So 9 times 6 is 54. And now all of that is divided by 3. All right, now that my fractions have common denominators, I can go ahead and add them. So I'll get x to the 4th minus 54 over 6x squared divided by 3. All right, so you can always think of a whole number like 3 as actually having an understood denominator of 1. So now this turns into a fraction division problem. So we'll have x to the fourth minus 54 over 6x squared times 1/3, which if we go ahead and carry out that, we should get x to the fourth minus 54 over 18x squared. So that would be your final simplified answer. All right, so let's look at a slightly more difficult one. So this one didn't come from the worksheet, but I think it's good for you to see an example where there's a problem on the top and on the bottom. So on the top, we have 2w over 3 plus 2, and on the bottom, we have 5w over 3 minus 15 over w. So both the top and the bottom of the fraction here are going to be their own addition problems. So on the top, we should have a least common denominator of 3. So let's set that up. And on the bottom, we should have a least common denominator of 3w, because 3 and w have nothing in common. Okay, so let's figure out our numerators. So the first one with the 3, the 2w over 3, that's not going to change because that already had our least common denominator. The 2 will become 6 because it had an understood denominator of 1. We multiplied 1 by 3, so we also have to multiply 2 by 3. Okay. In the first fraction on the bottom, from 3 to 3w, we multiplied by w, so we have to do 5w squared. So we're just multiplying by a factor of w. And then to go from w to 3w, we had to multiply by 3, so 15 times 3 is 45. All right, let's add these fractions together. So we'll have 2w plus 6 over 3. And then on the bottom, we'll have 5w squared minus 45 over 3w. Okay, so let's go ahead and write this as a division problem now. So we have 2w plus 6 over 3 divided by 5w squared minus 45 over 3w. Okay, so now we've got a division problem, so let's fully factor. So we pull out a 2, we'll get 2 times w plus 3 over 3 divided by, we can pull out a 5 and we're left with w squared minus 9 over 3w. So let's flip and multiply. So we have 2 times w plus 3 over 3 times 3w over 5 times w minus 3 times w plus 3. So that's just a difference of squares with the w squared minus 9, so I can factor that again. Now I look for the things I want to cancel. So 3 cancels with 3, w plus 3 cancels with w plus 3. And so I'm left with 2w over 5 times w minus 3. So last step, we just distribute that 5 back in, so we get 2w over 5w minus 15. All right, for our last couple of examples in this video, we're just going to practice rationalizing the denominator, and these are numbers 24 and 26 from the worksheet that we did in class. So this is 24. This is 26. So I'm just going to run through these really quick. So 9 times the square root of 9 over the square root of 7. This is a single radical in the denominator, and it's not added to any whole number. So we're just going to multiply this by the square root of 7 over itself. So you might notice on this one that actually 9 is a perfect square, so we can rewrite the square root of 9 as the number 3. So the top of this becomes 9 times 3 times the square root of 7 all over 7, which is 27 times the square root of 7 over 7. And that's as simplified as we can get because 7 does not divide 27. Okay, so finally let's look at number 26. So notice in the denominator of this problem, we have a whole number plus a square root. That means instead of just multiplying by the square root of 10 in this case, we need to multiply by the conjugate of 5 plus the square root of 10, which is 5 minus the square root of 10. And once again, good habit to always put these in parentheses so that you remember to FOIL or distribute. Okay, so let's write this as if it's being multiplied here. And finally, we just need to distribute across the top and FOIL on the bottom. So we'll have 5 times the square root of 7 minus the square root of 7 times the square root of 10 over 25 plus 5 root 10 minus 5 root 10 minus 10. So now we get 5 times the square root of 7 minus the square root of 70 over 25 minus 10, which is 15. So we do need to check really quick just to make sure that we can't simplify this anymore. So you would need to check that the radicals can't be simplified. Well, nothing really divides into 7, so we can't simplify that. And 70, you could check really quick a couple of perfect squares, like 1 and 4 and 9, 16, 25. None of those divide into 70, so we can't simplify this anymore. So this is our final simplified answer.